All right, so we're in section 4.5. So we're getting into solving um, exponential logarithmic equations. Um, I think the function is not appropriate, but um, I guess that's fine. So we're solving equations, and depending on how, yeah, you probably may have seen some simple ones. We may be getting into some that are a little bit more complex than what you would have seen in algebra. Um, so guidelines here for solving these. And this is how we'll do them basically. Um, but the first thing we want to do is isolate the exponential expression, and then we're going to convert it to a log equation one way or another. And then we can solve for the variables. So this first one, we have 3 to the x plus 2 equals 7. And really, so the exponential expression is already isolated. Um, and so we really just need to convert this to a log equation, which we have done uh, in earlier sections. So the three, oops, let's fix that. So the 3 is the base, and then these two are going to switch sides. So log base 3 of 7 equals x plus 2. Now I know WebAssign wants you on pretty much all of these, you have to enter the answer unsimplified first. So don't put this in the calculator. Just leave that. We'll bring the 2 over, and then there's the answer. So most of these, I think they're going to have you put the answer in like this in the first blank, and then put this in the calculator and get a numerical answer rounded to some place. So I'm just going to leave these here for now because you can probably put those in the calculator. If not, if you forgot or didn't watch the video from the last section, to put this in the calculator, so any base besides 10, or when we're using ln with the base e, uh, here's what you put in the calculator. And because most calculators cannot handle other bases besides 10 or e. All right, next one. So in this one, exponential expression is not isolated. So first we are going to need to divide by 8 to get that e to the 2x by itself. And so we have e to the 2x equals 2.5. And then we can convert this to a logarithmic equation. And I'm going to do it, we're essentially doing what we've done previously. But one thing you kind of want to get used to doing is taking the logarithm of both sides. And you can pick whatever base you want, but obviously you want to pick one that's convenient. And so if we're working with e, then we want to take the ln of both sides. So the ln and the e cancel out. So here we have 2x, and then over here just ln of 2.5, and then we're going to divide both sides by 2. And we get x is ln of 2.5 over 2. Now, this is the same thing as converting this to an exponential equation. If you convert this, or logarithmic equation, if you convert this to a log equation, you just kind of end up there. But sometimes it's not obvious, I guess, or convenient to just convert it to a log equation. Is easier or makes more sense to take the log of both sides. All right, the next one, e to the 3 minus 2x equals 4. So again, we can ln both sides. The ln and the e cancel out, so we have 3 minus 2x equals ln of 4. And now just solve for x and leave the ln4 alone. Then we'll divide by 2, and we'll factor out the negative, so we get 3 minus ln4 over 2. All right, now this next one is a little bit different. This is basically set up like a quadratic equation, except we don't have x, we have e to the x. So whenever you notice a 2x and an x, it doesn't really matter what's down here. Um, you can factor this as if it's quadratic, but we're not going to have x. We're not going to have x here or x here. We're going to have e to the x and e to the x. And so when you FOIL this, e to the x times e to the x is e to the 2x. So now we need the two factors of 6 that add to give -1, which is the coefficient there. And so that would be -3 and +2. So now we can use the zero product property and set both of these equal to 0. And we get e to the x equals 3. So x is ln of 3. And then we get e to the x equals -2, but this actually doesn't work. So if you remember from the graph of e to the x or any exponential, any basic exponential function, the range is from 0 to infinity. So -2 is not in the range of this. So there's no solution to that. You cannot raise any number to any positive number to an exponent and get a negative number. So if you ever get e to the x or any other number to the x that equals a negative number, there's no solution there. Okay, so that'll do it for this one, and then we'll get on to the log equations on the next one.